Okay. Okay, guys, we'll get started now. I see there's a couple of people missing. Are there people coming back? Are you just finishing a double class, is it? Or oh, yeah, okay, yeah. So how many people are we waiting on to come back? One there. Vanessa? No, one beside you. Nikita? Was there someone? Are we waiting for people beside you? What about Dasha? Oh, there you are, down the back, yeah. Yeah, he'll be back. Okay, so not that many then. Right. So what we're looking at in this class is practical problems. That is using exponential. Guys, come on, listen. Using exponential and log formulas and equations to help us with practical problems. So a typical exam type of question, there might be something like this. They give you the formula for the temperature of something, maybe a cup of coffee or something like that. And they might say it's something like, we'll say 20 plus A, E, B, T, minus BT. And they don't tell us the A and the B in the formula. And they might ask us to find the A and the B, but they would have to give us more information. So they could say something like, when T is 0, the temperature of the coffee, theta, well, we could say it's something like 60 degrees. And then we could say, I should say what the units are. T is in minutes. And the temperature is in Celsius. Okay. And we'll say maybe 5 minutes later, the temperature, maybe it cools down to, we could say 40 Celsius, something like that. 40 Celsius.
Like a cup of coffee, yeah?
Yeah, something like this. So, it'd be a multi-part question. The first part is normally to find A. Then the second part will be to find B. Then the third part is they might ask you for the temperature after 10 minutes. So they might say, find theta when T is 10. And then the last question they might ask is to find the final temperature, meaning the temperature the cup of coffee would become if you were to leave it out for a very long time. So let's do this one together. I'll just let you write down the information first, and then we'll do the 4 parts. You got that written down? Oh, and there might be a 5th part, but I'll do that in a moment. Find when the temperature is 30, for example. Celsius. Okay, so there's 5 parts for us to do. Final temperature, yeah. Okay, yeah. Can I scroll down? Yeah. So the first part, finding the A, that is not that bad to do. You simply sub in the values. So at the beginning, the temperature is 60. And this will equal 20 plus AE minus B times 0. Now, b times 0 is obviously 0, and e power 0? 1. So I hope you can see clearly what the a is. 40. Yeah? Yeah. Now, a little bit harder now. That was part 1. Part 2, finding the b. Find b. So we can use the second piece of information here. 40. Isn't it? Yeah, 40. No, I think, hang on, sorry. The a is, yeah, sorry. 40 equals 20 plus 40 e minus 5b. Because the t is 5. Yeah? So this becomes 20 equals 40 e minus 5b. So that becomes 0.5 equals e minus 5b. Now what do we use next? Logs, yeah. So what do we say exactly? We can say that minus 5b equals what? 0.5.
Yeah,
E to what power gives me 0.5? Log tells us what the power should be. Yeah? So if we divide this by minus 5, I can get the b. What's the b, please? 0. Okay. 3. Find the temperature when 10 minutes have passed. So that means theta equals 20 plus 40 e minus 0.139 times 10. And that gives us the temperature after 10 minutes. What's that? What is it? 49.3, is it? What? 29 point. So if I do one decimal place, 29 point. 30 point. Oh, 30 even. So yeah, it rounds up down to 30. Okay. And then 4, find the final temperature. So we need to have a look at the formula to figure that out. Theta equals 20 plus 40 e minus 0. I need to change this question because it's stupid now. 35. Okay. 0.139 t. So what is the theta trying to become as the t is getting larger and larger? Who can see? Yeah, so what will it become in total? Yeah, what number? No? Here's the formula. So what is the theta trying to become? Dasha, what did you say? 20, yeah. Because what happens to this piece as the t gets bigger? Yeah, near 0. So this will become, or is trying to become 20 Celsius. Because you're just going to be left with this piece. Yeah, we did this one in class, remember? Yeah? You have to look at what's happening. So remember we said, with the graph, do you remember the graph for minus power? It's decreasing to the x-axis. So it's becoming 0. Remember we did the 4 graphs. The last part is find when the temperature is 35. So 35 equals, what's that, 20 plus 40 E minus 0.139 T. Okay. We can solve this one. We just have to rearrange it a little bit. So if we take the 20 to the left, what do we get? 15, isn't it? And then what we do, we'll divide by 40. 0.375? Okay. E minus 0.139 T. How do we get the mystery power here? Log. So mystery power equals log what? 0.375. So again, scratch that out, bring it under. 337. No, that was 139. Sorry. Minus 0.139. Okay, so what do we get for the T there, please? 7.056. So 7.06 minutes. Yeah? I would like you to convert that into minutes and seconds, please. And anybody who says 7 minutes and 6 seconds gets a slap in the face. So, what is it? 7 minutes and how many seconds? What's about?
I want to say 6.
About 4 seconds, is it? What is it? 3.6. Yeah, so if you round it off to the nearest second, it'd be 4 seconds. Then. 7 minutes and 4 seconds. Okay. Right, okay, that example I just did for you there, that would be such a standard exam question, like really, really standard exam question. Not too difficult, not too easy. Basic, medium difficulty here. So please write that down carefully. We'll do another one. Yeah, because of the multi-part element to it, yeah. Have you got that written down?
How are we getting ln? It's log of e, and how we transfer that?
Well, I'm just saying, basically what I'm doing is I'm putting ln on both sides. And then dividing by the coefficient.
Yeah.
That's all, really.
Yeah.
Guys, ready for the next part? Yeah. The next part is a chemistry example. Have you done pH with Lorraine? No? Not yet. But you would have done concentration with her and molars. What? Have you done moles? No. But you've heard of moles before. Moles per litre. Yeah, okay. Alright, so we'll have a look here now at this one. So, in chemistry, you've all heard of pH level. If it's less than 7, it's a acid, and more than 7, base, isn't it? Yeah, and 7 is neutral. The formula for calculating pH is minus log base 10, what? Concentration of what? Just like this? H plus, yeah. The concentration of positive hydrogen. Yes? Now, for those people who don't know concentration, what's another way of saying concentration? Just how many moles per litre? Isn't that usually how you measure it? Moles per litre? Yeah? Per AMU? Yeah. Yeah, and so is liters. I think. Well, anyways, we'll use liters. Okay, moles per liter. Yeah. Now, guys, listen. Listen. So, for example, let's take something like apple juice. Guys, come on, listen. Apple juice. Listen, please. So we'll take something like apple juice, 200 milliliters, and we'll say it has a pH level of 3.5. And my question would be to work out how many moles of H plus do we have? And just to be clear, if you don't know what concentration is, it's minus log base 10. The number, I'll just write it like this, the number of H plus divided by the volume. And usually it's per litre, but in this case we have 200 mils. So there's a couple of ways you could think about this. If you want, you could work out how many H plus is this not it, or?
No, I'm asking what is your please.
I want to know how many H plus actual ions there are in 200 mils of apple juice. So my question is, what is the number of H plus in this glass of apple juice? So one way you could do it is work out what it is for 1 litre of apple juice and then simply divide by 5 to make it 200 mils. Okay. So let's have a look here. pH is 3.5. That's equal to minus log base 10. And the concentration, remember we said, is the number of H plus over the volume. Now what we can do is look at it for 1 litre and then fix our answer. It'll make our life a little bit easier. So we imagine we have 1 litre. Because if I'm dividing by 1, of course that's much easier, right? So now this becomes 3.5 equals minus log base 10, number of H plus. How can I work out the H plus? Yeah, so what I'll do is I'll just take the minus over to the left, okay? Yeah, and that's it. We remember the definition of log. So it says 10 to the power of minus 3.5 is equal to the number of H plus. It's be pretty small. What is that?
3.16 times 10 to the power of
3.16 moles. Okay? But that is in 1 litre. Moles in 1 litre per litre. But we don't want 1 litre. How many do we want? 200 mils, which is a fifth of a litre. So if you divide this number by 5, what do we get?
6.3 to 10 to the power of 5.
Moles in 200 millilitres. But, what's wrong? It's okay. But, I said how many? I actually want to know the physical number, not the number of moles. So what do I multiply this answer by? If I want the actual number, not just the number of moles. Multiplying by Avogadro's constant. Yes. So 6.02, 10 to the 23. You're going to do all this in chemistry, you know. So what do we get now if we were to put that in?
What is it? 6.2.
Isn't it 6.02 is Avogadro?
Yeah.
No, it's not minus 23 for sure. It's definitely plus 23.
Yeah, it's like different volume. But I think 2.4 probably.
It depends.
Chemistry, yeah.
It'll depend on the class, perhaps.
Yeah.
Some schools will just use 6. What? Yep.
3.807 times 10 to the power of 19.
Ions of H plus in 200 milliliters of apple juice. So, we worked out the actual number of positive hydrogen positive hydrogen ions in 200 milliliters of apple juice. And all we really needed to know was the pH level of the apple juice. Yeah. Okay, write that one down. Yeah.
So the law, when you change it from negative to positive, you divide both sides by -1.
Basically, yeah. Yeah. I have to think of something. I haven't decided yet. Last year I was Clark Kent. And the year before that, I was Stephen Hawkins. Yeah. I took a chair from the office, I put on a Stephen Hawkins mask, and I got a voice synthesizer on my tablet and stuck it to the arm of the chair. I know! Really, really out there. So, I'll have to think of something controversial this year, perhaps. Maybe even a little bit racist. Don't know. Still thinking about it. I'll do something. It's just a question of what. Yeah. How risky do I want to go? You know. I have a couple of ideas. I need to go to a charity shop and see if there's anything that I can find too. The best costumes are the homemade ones. You know, so I'm not going to do something stupid like spend €60 in a costume shop. I want to. Has somebody done that? Was it you, Dasha? Who was it?
Like,
what?
It wasn't Dasha wasn't related to this conversation at all.
I just saw her reaction. I saw her shaking her head. So, were you? All right. Were you agreeing with me? Was it? I think the more controversial the costume, the better.
Yeah.
That's my philosophy. Something controversial would be good. Now, not too controversial. You have to get the right balance, you know?
Last time I was in the costume of pop.
Huh?
The ones that's the actual face.
What? I don't think he was saying popcorn. That would be an interesting costume, all right. What have you got?
Yeah.
Hope. I was thinking something similar this year. Hope. Yeah.
Yeah, and the previous year it was like Executor. Yeah, but it wasn't really looking like Executor.
I was thinking something similar.
Because it was like
Yeah. Anyways, we'll think about it.
I was already in the
maybe-
international school, so
Would it be too offensive if I go as Putin? Putin?
yeah, do it, please do it. It's like
Vladimir Putin? Ah, come on.
where can you find the mask?
The leader of Russia.
Are you? Oh my
Vladimir
god.
Putin. Oh, they don't know. They don't know
Can you
anything.
please give me the mask of
I have to see if I can
I
find
will
one.
be beaten by my friends.
I'll see if I can find one. All right, we'll continue. Another example now. So, this next one now, we're looking at something called carbon-14. Has anybody heard of carbon-14? Yeah. So what is carbon-14 used for? Yeah. So what do you use it for though? What's it? Yeah, but what does it use for? Yeah, but why is it useful? Carbon dating, yeah. You can age. I can't hear when there's more than one, so listen. You can use carbon-14 to tell how old something is. Okay? And the way carbon-14 works is it decays exponentially. So when you look at something over time, the amount of carbon-14, at the beginning it has all its carbon-14, which might only be like a few grams. I don't know how much carbon-14 might be in a person or whatever, but we'll just say it begins with 100% of its carbon-14, whatever number that is. Let's say it might be 2 grams, whatever it is, it doesn't matter. But we'll say it begins with 100%, and then as time passes, it decays. And it decays like this. Yeah. So which graph is this we've seen? The exponential graph. The A is positive or negative? Which the A positive and the B negative. Okay. So the way carbon-14 works is at the beginning, so when the time 0 has passed, you have all the carbon-14. So the carbon-14 is 100%. And then, so then, does anybody actually know how much time passes until the carbon becomes 50%? Does anyone know this?
After death, or like?
Oh, the 0 is at death. Time 0 is when the organism died. Good man. You knew it just like that, huh? Right, so after 5,730 years, the carbon will be at 50%. Okay? So you can see it takes a very, guys listen, David, it takes a very long time for the carbon to decay. It takes nearly 6,000 years to lose half the carbon-14 in the dead organism. So normally what happens is most archaeologies, what they find is something that used to be alive. So like if you found paper, the paper obviously was from a tree that died to make the paper. So once something dies, the carbon begins to decay. Now it only decays once the organism is dead. While it's alive, it stays at the 100% level. And then when it dies, it decays. And the reason for that is because the carbon is always decaying in living organisms, but when they breathe in or when they eat, they kind of top the carbon-14 up. So when they die and no longer eat or breathe, then it decays away. So you have 2 pieces of information here, and you have a formula. You know that the carbon is going to be exponential. So that would be A, E, minus B, T, like that. So I'll let you try this before I do it. There's going to be 3 parts to this question. Part 1, unsurprisingly, is going to be to find A. Part 2, again, unsurprisingly, is going to be to find B. And then part 3 here, you find something that has 79.5% carbon-14 remaining. So you dig something up, you measure its carbon-14 percentage, and you see that has about 80% of its carbon-14 left, and you want to calculate T. Now before you do part 3, you could roughly estimate the answer. So how long did it take to get to 50%? About 6,000 years. So any answer that's kind of around about the 3,000 years, maybe more, maybe less, would be good. If you got an answer that was more than 6,000, then you've obviously made a mistake. You know. Okay, I'll give you a minute, and then I'll do the question on the board. Give me those 3 parts. work it out now? I think the B, was it the B that you just got? It should be a really small number. Yeah. Okay, how are we doing here? Do we have answers yet? Maybe? Yeah. You got an answer, Nikita? Maybe?
Absolutely.
Will we have a look at it now?
1 second.
1 sec, okay. Got an answer? You think so? What did you get for T? Oh, go on, don't be shy. What you get? Oh, go on, what you get? You know what? Yeah, it's not right. It's way too small, isn't it? Yeah. No. What you got for T? What you got for T? Five.
Thousands.
Yes. How many thousands though? Don't make me pull it out. What did you get for T? How many thousands?
1,800.
Yeah, seems believable. From what I remember, it was around about the 2,000 mark. But I thought it was a little bit more than 2,000 though. Did anyone else get an answer for T? What did you get?
1,000.
Okay, all right. So it's a little bit less than 2,000 then, right? So, what is the A here? Yeah, because you'd say 100 equals A E0. So now you have A done. C equals 100 E minus BT, and we sub in the second piece. 50 equals 100 E minus 5730B. Yeah? Divide by 100, we get 0.5 equals E minus 5730B. So minus 5730B equals log 0.5. Divide again. And what did you get for B? Pretty small number, huh? Like that. Yeah. 0.000121. Yeah? Yeah, that's fine. That's fine. Yeah. Part 3 now. You are told that there's 79.5% carbon 14. This is equal to 100 E minus 0.000121 T, and you want to get the T now. So again, by dividing, you get 0.795 equals E minus 0.000121 T. And once again, what do we use here? Log 0.795 equals minus 0.000121 T. So dividing, and we get T is 1. Okay, and actually I didn't say this, but in the question I wanted this one to 2 significant figures. So if it was 2 significant figures for this answer, what would it be? 19, isn't it? Here's them. So anybody who knows a little bit about history, this is a famous example. It's the Dead Sea Scrolls, if anybody's heard of those. So these are 1,900 years old. They were discovered. Okay, have you got that one written down? Yeah? So, Ishpreet, what went wrong? You put the wrong value in for B. Yeah, okay. Right. Question? No? Okay. So there's a few minutes left. What I want you to do, just like with the other practical problem lesson, it's really, really good if you can do all of these. Okay? Now there's 10 questions there. If you got all of them done, then you're well prepared for the exam. Okay? So you can get a start on them now. Question 1 is just like my first example, so you should at least get number 1 done now. So get a start on those, please.